All right, before we get into one-to-one functions, we should review what we mean by a function inverse. We know that every function f has an inverse, which we write as f inverse, as you see on the screen, but we have to be careful that that inverse is also a function. Otherwise, that's going to restrict some of the things that we can do with inverses. Now, a function takes an input value, does something with it, and produces an output value. The function's inverse, therefore, is going to tell us what input value goes with a given output value. So in other words, a function's inverse undoes a function operation. For example, subtraction undoes addition. So if I have f of x equals x plus 3, then the inverse, f inverse of x, is going to be x minus 3. Division undoes multiplication. So if g of x is 4 times x, g inverse will be x divided by 4. Logarithms undo exponentials. If k of x is 5 to the power of x, then the inverse is going to be logarithm to the base 5 of x. These are all opposite operations that undo one another. So in order to calculate the inverse, we're just going to change f of x to y, switch x and y, solve for y, and then replace y with f inverse. And we saw that on a previous video. So how do we know if a function's one-to-one? Well, a function f is one-to-one only if its inverse is also a function. In other words, both f and f inverse must be functions. So a couple of examples that hopefully you can relate to pretty easily. If you have a student ID number, you can get a grade level from that. Whatever your student ID number is will tell you what grade you're in. Okay, but you can't pick a grade level and come back to only one student ID. So a student ID number tells you one grade level, but a single grade level can tell you multiple values for student IDs because there are more than one students in each grade. So that particular function is not one-to-one. Now, if I have a student ID number with a student name, that can be one-to-one because a student ID number will correspond to one particular student, and one student only has that one student ID number. Okay, so how do we tell if a function's one-to-one? By looking at the information we have. Well, if we have tables, we have to have non-repeating x values, which means f is a function, so we're familiar with that already. But we also must have non-repeating y values, because if you remember, these are going to be the inverse's x values. Okay, so those are the inputs coming back. If we have an algebraic expression, it's a little harder to tell just by looking at it, okay, but it turns out that in order for a function to be one-to-one, it needs to be strictly increasing or strictly decreasing. If it has any maximum or minimum points, any turning points, it's not going to be one-to-one. Okay, because if it does have a turning point, that means that we're going to have repeating y values. And you can sketch a graph and just kind of visualize that yourself. Now, if we're looking at a graph, we know that it has to pass the vertical line test, and that tells us that f is a function, and it's going to have to pass what we call the horizontal line test, which is going to tell us whether f inverse is a function. So how do we know what the horizontal line test is, and how does that work? Well, let's see that right here. So how does a horizontal line test tell us if a function is one-to-one? Well, let's go and take a look at this graph right here, which is a function f of x equals x squared. We know it's a function because if we apply the vertical line test, we see that we can sweep this vertical line across the function, and at most we get one y value for every position of this vertical line. And the reason for that is because every position of the vertical line basically is choosing one x value. And at each x value, I should only have one y value at the most, in this case, this y value. Okay, how does that help us with determining whether the function is one-to-one? Well, I'm going to turn off the vertical line for now, and we're going to take a look at our inverse of x squared. Now, the inverse is in green here, and the inverse is square root of x, because we know that to undo a square, we're going to take the square root. So you may be thinking right now, well, wait a minute, this is not the square root graph that I remember seeing. The square root graph I remember only has the top half, which is shown here now. So I've taken off the bottom half. This is the familiar shape of the square root function. And notice that I said square root function because what we do is normally we only consider the positive root. Okay, if we take square root of 9, for example, we say that that's equal to 3. And we do that because we want this graph to be a function. Notice that if I actually look at the inverse of this x squared, I'm going to have a graph that is not a function. And let's take a look at the vertical line test here, for example. If I go to x equals 4, okay, right here, it's telling me that I want the square root of 4. So, no surprise, the top half of the graph gives us the square root of 4 is equal to 2. But we also know that the square root of 4 is equal to negative 2, because if we square negative 2, we're going to get positive 4. So the vertical line test on f told us that yes, indeed, that was a function. So the vertical line test on f told us that yes, f is a function, but what we see by looking at the graph is that the square root, which is the inverse of f, is not a function because the vertical line is passing through that graph in two places and not just one. All right, so the question is then, how does this go back to the horizontal line test that we can do on f? Well, think about it. If we're not going to have a graph of square root of x, of the inverse of the function that we're dealing with, if we don't have a graph to look at, we really can't do a vertical line test. But consider that this vertical line has an inverse itself. A vertical line at x equals, let's say 5, this is pretty close to 5, is going to be a horizontal line at y equals 5. We're just going to reflect this vertical line over the reflecting line and get a horizontal line. Now notice that this horizontal line passes through f in these two places, which is the exact inverse of the vertical line passing through g in these two places. So if I eliminate from the graph here the graph of g, and let's turn off the vertical line for a second. Now what I have is a horizontal line that is sweeping through y values to see how many x values I have. So if I select a y value of 4, okay, so x squared equals 4, that gives me two x values that I can associate with that output, positive 2 and negative 2. So the horizontal line test tells us whether the inverse is going to be a function or not, because basically the horizontal line test on the function is equivalent to a vertical line test on the inverse.